Welcome back. I'm going to include a second PowerPoint in this unit, and the purpose for this PowerPoint and some videos that we'll see along with it is to show us how Excel can be used as a tool that makes our process of linear programming a little less cumbersome, and that we don't have the pain in the neck that graphing can turn out to be on some of these systems, some of the inequalities for our systems of constraint. So let's go over and let's share the PowerPoint, and we're going to run through the beginning notions of how you get Solver into your Excel app, and then the process of thereby you and I will attempt to solve a linear programming problem with Excel. So I cleverly called this using Solver in Excel. All right, so you already know this linear programming process can be tedious, particularly if the inequalities are not exactly kind scales. So Excel gets us an opportunity whereby we can rely not at all on the graph, but more on you and I setting the algebra in motion to create a good objective function, a viable system of constraints, and then therefore it will attack and solve for us. So we kind of like that a lot. In my experience, it works really well sometimes. Sometimes it gets to be a bit finicky. So yeah, you might have to take the good with the bad as we go. But at least it sets the process of doing all the heavy number crunching for us and saves us some hassles there. Okay. So what you got going on, Dell? Well, I'm going to try to figure out if you need to add Solver to your particular Excel. How do you go about doing that? And then once it's there, nothing better than looking at how it would solve, how it would aid us in the solution of a linear programming problem. So, all right, excuse me, objectives if you like them. All right, if you don't have Excel, if you open your Excel now and say, man, I don't see Solver, man, I don't know what I'm going to do. This is going to be difficult. In all likelihood, you're going to have to add Solver to that ribbon that you see when you open Excel. So if you need the process detail to help you do it, this slide suggests what we will do. Okay. We'll click on File, we'll go to Add-ins, and I would suggest you just type Solver in the search bar and it should locate it for you. And then you can add it. Now I'm hoping that here at campus, if you're using a school computer, we don't run into an administrative issue. If we do, all right, then that might be something I have to have the IU, the the people who are in charge of the purposes to help set it up, and we'll get them on board if we have to. But if it's just you at home, you probably have administrative capabilities on your system, and we won't need the tech department to do that. All right, after you've done that, if you look at that ribbon on your home tab, you should see Solver listed as an option. And this is just a snapshot of my screen. And you see that all the way over to the right, and I put a lovely red circle around it, you see Solver as an add-in. And actually, I've opened it on this screen and I was playing around with it earlier, but that's where it shows on my screen after I added Solver to my main ribbon there on Excel. All right, and that's the Home tab on your Excel ribbon. Okay, so I thought what we would do is we'll create a problem, we'll set it up, and then we'll get Excel to help us with the processes of finding the maximum value for our objective function. So, all right, that's us. Set it up, get your max, get your min, whatever your objective function is. Find your system of constraints that leads to the feasible region, but we're not going to look at the graphs. We're going to let Excel do all the heavy lifting. Okay. So in a simpler fashion, what we saw in the last PowerPoint, you've got to clearly define your variables. You've got to create that system of constraints, and then you'll have to tell Excel what you created. And my pledge is to create something that's easy to look at when you build that sheet. Don't make it too vanilla. Don't make it too generic. Put some labels in there so that somebody looking at it has an idea what it is that you're attempting to do with that sheet in Excel. When we get around to seeing the example for this, you'll see what I mean very clearly. And then you're just going to go ahead and have Solver help do the work. Okay. System of constraints we're familiar with. You're going to have to put something in there that talks about the left side of those constraints versus the right side of those constraints. And again, when you get to see the solution in Excel, which will be a separate video, you'll see exactly what that reference point means. But again, I'm going to pledge that my labels should help make things clean for us as we look at it. Here's the problem. We got Sparky and Sally, and they're going to do some copy packets and some, they're going to make flyers and oh, it's going to be great. It's just going to be great. Okay. Um, so you got all kinds of things in there. They got a certain restriction based on how much ink they have. They got double-sided brochures and it's going to be just glorious. All right. So you read the problem. There's a lot there to digest. I'm going to pause for a second and just let you read it. So as you read, your first challenge is, what are my variables going to be? Well, what are you asking me to keep track of? Then what is it that I want to maximize? Well, this one's easy. I want to maximize profit. Okay. It looks like my options are to make flyer packs and brochure packs. Okay. So that's all right. I can make flyers and I can make brochures. And the question says, how many of each should we make if we want to maximize profit? All right, so let's tear it apart. Let's represent our variables. Let's build our system of constraints. Let's create our objective function. And then we'll move Excel into the image, and we'll take a look at how Excel and Solver can go ahead and help us produce what we need. All right, so let's define variables. Again, I'm old school. I let X and Y play what I'm going to do. I let X be the number of packets of flyers. I let Y be the number of packets of brochures. You don't have to do that, but for the example that we're looking at, that's what I chose to do. All right, so then that's pretty cool. I got those things out there, and now I have to go digging through that problem and try to find out what kind of constraints, what kind of restrictions do I have being placed on me based on, maybe how much ink I have, maybe how long I'm going to work on this project. Okay, so that's our next challenge in life. All right, so, you know what? Well, let's go out of order. Let's create the objective function first. What we know is that we can make a profit of $10 on each pack of flyers. We can make a profit of $20 on each packet of brochures. So the objective function referencing those variables would look like this. P for profit. I thought that was pretty cool. $10 for each flyer pack. In addition, $20 for each brochure pack. So that's our objective function. That's what we seek to maximize. So we'll be trying to find values for X and Y that we could plug in there and go ahead and find out what value makes a maximum profit. All right, time for constraints. Relative to ink, we have 60 units of ink that we can use. It takes 1 unit for each pack of flyers. It takes 3 units for each pack of brochures. We got paper, takes 20 sheets for each packet of flyers, takes 10 sheets for each packet of brochures, and we have a max at 500 sheets of paper. And we got labor as a constraint, right? We can only allocate 72 hours total, takes 2 hours for each packet of flyers, takes 3 hours for each packet of brochures. So that's synopsis of content from that problem that might be useful as we develop our system of constraints. Okay, here we go. Well, how'd this show up, Dale? All right, well, let's talk about ink. It takes 1 unit for each pack of flyers. That's referenced by X. And it takes 3 units for each pack of brochures. That's referenced by Y. And we can't use more than the 60 that we have. That's that first inequality right there. Second inequality has to do with paper. All right, it took 20 for each of the X's. It took 10 for each of the Y's. We got a max at 500 sheets. What we could do there, if you want, is we could go ahead and divide by 10. I did not on this example. If I were doing this problem, particularly if I had to graph it, I would have. I would have divided that second equality by 10. But with Excel and Solver, I didn't worry about it. I let it as is. Third and final inequality down there says, all right, 2x plus 3y has to be less than or equal to 72. That's relative to time usage or to labor usage. 2 hours necessary to make each packet of flyers. 3 hours necessary to make each packet of brochures. Can't exceed the 72 hours. That's our system of constraints. So we have our objective function that talks about profit relative to these particular sets of constraints. I should add that what we saw last time in that X had to be greater than or equal to 0, and the same thing being true about Y having to be greater than or equal to 0 would also be in play. So if you want to list those as part of your system of constraints, you certainly can. You'll see when we get to solve or how we kind of add that in, and that's maybe not why I listed it here. Okay, but those are constraints. You certainly can't have a negative number of packets of flyers. So we've achieved what we set out to do. We created our system of constraints, and we have our objective function. All right, so the next thing we're going to do is head to Excel. We're going to play this a little differently. I'm going to wrap this video here, and we'll open another video that doesn't have anything to do with PowerPoint, simply contains the solution to this first problem. We'll see you at that video coming up soon.